Hi guys, today we're going to talk about special types of linear systems. So there are three different possibilities for how many solutions are possible in the linear system. In last class, when we talk about solutions of systems of equations, we always graph those two equations and see where they intersect. So if the lines intersect, that means wherever they intersect, that will be your solution, and we always write that in order pair. You guys remember? So in this case, when the line intersect, that means we have one solution. Okay. Don't worry about this blank line. Okay. But then let's take a look at the next one. What if lines are parallel? Let's see. Two lines are parallel like this. One goes like that, and the other one goes like that. And when we talk about system of equation, the solution is where they intersect. Point of intersection is the solution. But in this case, lines are parallel. So how many solutions would you see? You don't see any intersection. That means there is no solution. Correct? All right. How about the next one? What if lines coincide? What does that mean? Lines coincide means one line goes like that, and the other line goes right on top of it. So even though there are two equations, you only see one line because line is on top of each other. In this case, how many solutions do you see? How many times do they intersect? On every single point, they intersect. So the solution will be infinite. Solutions. Very simple, right? So if the lines coincide, that means if the lines are on top of each other, infinite solutions. If the lines are parallel, that means no solution. If the lines intersect, there is one solution. Now, turn to the next page, then you will see three different examples. What I want you to do is I want everyone to graph those two equations for each example and see how many solutions they are. So make sure when the equations are written in somewhat standard form, this is not exactly standard form, but somewhat standard form, we gotta change them into slope-intercept, and then we graph it and see the point of intersection. So pause the video. I want everyone to try example 1, 2, and 3 by yourself. And once you're done, you can check your answers. Please pause the video. Okay, did everyone finish? So if you look at the first example, your answer will be no solution because two lines are parallel. And even before we graph those two equations, you can see y equals 3x minus 4 and y equals 3x plus 7. They have same slope of 3, but different y-intercept of -4 and +7. Therefore, they are parallel. We can see that right away. If you look at the next example, y equals half x minus 1, y equals half x minus 1, they're exactly the same equation. So before even graphing it, we know that they're coinciding. And even though they look different in standard form or like somewhat standard form, when you change them into slope-intercept, they can be the same. Same thing for example 3. I didn't even get to graph example 3, but I can see it. Y equals 3x minus 5 and y equals 3x plus 12. They have the same slope of 3 and different slope of a different y-intercept of -5 and +12. So those two lines are parallel, and therefore there are no solutions. Does it make sense to you? All right, that's it for today, and have a good day.